Let's check whether the given star operation here defined on Z, the set of integers, as A star B is equal to A to the power of B, whether it is commutative or associative. To do that, let's start with commutativity. So commutativity. For commutativity to hold, we need to establish that A star B is equal to B star A for A and B, both elements, or for all A and B elements of the set Z, which is a set of positive integers. Of course, let us have here let A, B, and add C, element of Z. I'm adding here C because we'll be using that for associativity later. So we're going to establish it like this. Okay? So the first one here is if we have A star B. If you have A star B, it is actually given already. Our A star B is given as, we have here A to the power of B. That's already given here. Okay? So that's A to the power of B. However, B star A is actually in this form because we started with the element B, okay? Because that's the structure of this operation here. So you have B to the power of A. Now, A to the power of B is not necessarily equal to B to the power of A unless if B is equal to A, as long as they are not equal to 0. Okay? So if B is equal to A, they will have the same result. But we are talking about for all elements of A and B in Z. So this is not true all the time. That would mean that A star B is not the same as B star A, which means that star is not commutative, because we need to establish here for all elements of A and B, not just for a specific element. Okay? So with this, it's not commutative. Let's try to find out if associative will also not hold, or will it hold here. So we need to show that A star B, the grouping of that, star C is equal to A star the grouping of B star C. Let us have the left hand side. You have A star B star C. So we start with A star B as the grouping symbol first. This is actually A to the power of B. And this will be subjected to star C. Take note, this will be treated as one term. In short, this would be our new A if we're looking at this. And our C is our new B. So if we're going to establish this, that means this will be A star B is your A. This would be raised to C. Okay? That's how it goes. We have A star B to the power, A to the power of B to the power of C. And by means of, what they call this one, power law, you will have here A to the power of B, C. This is the result for the first grouping, A star B, then star C. Okay? Hopefully you're following that. Let's proceed to the next one. A star B star C. Let's find out if this would be the same as earlier. So we'll have it here, this first grouping symbol. B is our first, that's our A. That will be our base now. And C, our second, will be our exponent. So A star that. Again, this will be treated as 1. Right? Therefore, this would be our new base, A. And the exponent would be B. Not B times C, but B to the power of C. Okay? So this here earlier, we have the product of B and C as the exponent of A. But here, we have the power of A is an exponentiation, which is B to the power of C. Well, for all values of A, B, and C, again, we're talking about for all, A to the power of BC is not always the same as A to the power of B to the power of C. Okay, this would mean that A star B star C is not necessarily the same as A star B star C for this given item here. That would mean, let me use the space here at the bottom and change this to black. You will have here, your star is also not associative. Okay, so for both commutativity and associativity for star operation defined here, it's not commutative. Both of them will not hold using the definition a star b is equal to a to the power of b. So this is how we do it for this given star operation. Thank you very much for watching.